Today, we're going to talk about manual flushing. If you've been with us for the past week or so, we've talked about intelligent flushing, we've talked about automatic flushing, and of course sampling stations. And conventional or manual flushing kind of falls into the same line with intelligent and automatics. And we'll talk about the differences between the three of those as we go forward. But again, we're back to the dead end danger zone. We'll briefly talk about, the reasons why people flush water lines. When I first got in this business years ago, I thought, why do they flush water lines? Water's water. But as we've talked about before, when you add chlorine to water and you chemically change it and that water ages, bad things happen. Especially on dead end mains and distribution systems where the water is not recirculating with the rest of the system. And if you don't have enough connections on that line, houses or businesses that are turning the line over, that's where we get some stagnant water issues and these dead end danger zone situations. So let me get Manuel is going to come in here. We'll get him connected. So then we're going to talk a little bit again about this very briefly about the dead end danger zone. So let's go ahead and jump in here. So what does water age have to do with water quality? Like we talked about before, when you add chlorine to water and it ages, bad things happen. Two dynamics happen pretty much at the same time. Uncirculated water, disinfection residuals decline. So just like in a swimming pool, chlorine dissipates. So it disappears, even in a pipe 4 feet underground. Over time, chlorine will dissipate, and that's why we need to turn the lines over to get new water in, get old water out, and bring those residual levels up and keep them steady. The other dynamic that happens at the same time is this thing called disinfection byproducts. Disinfection byproducts occur when organic material in water comes in contact with chlorine, and we'll talk about that here in a minute. So again, we're talking about kind of the same things that are happening with the dynamics of water, and we'll talk about manual flushing here instead of the automatic and intelligent. So again, residuals, like we said before, a good yardstick for water quality on a dead end main is about a week. If my water is less than a week old in a dead end main, I'm usually pretty good. It's when it gets beyond a week that I start losing residuals and I start having disinfection byproducts form. Free chlorine, which most systems use in this country, sodium hypochlorite, it dissipates at a rate of about 1.5 ppm per week after the initial 200 hours or about a week. So the first week it stays in the system very well, pretty consistent. And then after that first week, it drops off very quickly. Chloramines or combined chlorine stay in the water about twice as long. So the first couple of weeks, it's very steady. And then the dissipation rate is a little less than free chlorine. It's about a 0.625 per week instead of a 1.5. So just know that over time, chlorine dissipates, and you want to try and keep your water age, especially if you're using a free chlorine, less than a week old. If it's more than a week old, that's usually when you start seeing residuals start dropping down to close to 0.2 ppms or less, sometimes even down to 0, depending on where that dead end is located in your distribution system. Most states require a 0.2 ppm disinfection residual level. It's done at the state level. Some are higher, but most are usually at a 0.2 minimum. The same with Canada, it's a 0.2 minimum ppm per for the residuals. Once the residuals fall below the minimum, again, they're unable to control the growth and spread of microbial pathogens. And this is why we put chlorine in water to begin with to make it safe to drink. The EPA's recommendations are actually at 0.5 milligrams per ppm to a 4.0 maximum, but most states, again, set the parameters, and most have these at a 0.2 ppm or milligrams per liter. The second dynamic that we've talked about before is this thing called disinfection byproducts. So once again, although disinfectants like chlorine help to eliminate and control the growth and spread of microbial pathogens, they do carry a side effect. So just like pharmaceutical drugs, like we talked about when you watch those commercials on TV, they talk about all the great things that the drug's going to do for your health if you have a certain condition. And then the second half of the commercial talks about all the side effects. And the side effects are the same, similar to the ones with when we put chlorine. Chlorine is like a drug. We put chlorine in water to make it safe to drink. But there is a side effect of putting chlorine to water, and that's these things called disinfection byproducts. When naturally occurring organic material in all water, whether it comes from the ground, a reservoir, a river, a lake, doesn't matter. All water has a microscopic, naturally occurring organic material in it. And when those organic particles come into contact with chlorine. Chlorine transforms those particles into toxins that we call disinfection byproducts, trihalomethane, haloacetic acids, and when consumed over a period of time, they can cause liver cancer, heart disease, nervous system activity decrease. They even think there might be a link between Alzheimer's and disinfection byproducts. The EPA has known about DBPs for some time, since the late 70s, and thus we've had our stage 1 and stage 2 disinfection byproduct rules implemented. We're currently under the stage 2 rule, and now you need to take your quarterly samples and stay below the certain levels of DBPs that the EPA prescribes. If not, you have to take action, and an easy action for controlling DBPs is flushing dead-end lines, especially to bring your DBPs out, get the old water out, bring the new water in, get rid of that old water before your disinfection byproducts start to form. So again, disinfection byproducts can begin to form in 4 to 7 days. That's why I like to use a good yardstick of about a week. If my water's less than a week old than a dead end, I'm probably not gonna have residual issues. I'm probably not gonna have disinfection byproduct issues. But if it goes beyond a week, that's where both dynamics start to happen. My residuals start to disappear, and my disinfection byproducts start to form, okay? These are the levels that the current EPA currently prescribes for keeping under the levels of THMs and HAAs. So like we talked about before, flushing dead end is one of the easiest, it's really one of the easiest and best, cheapest methods to maintain water quality, especially on dead end mains. Flushing lines on a regular basis, make sure that your residuals stay very steady and you get the old water out before the disinfection byproducts start to form. Now, in the past, we've talked about intelligent flushers and automatic flushers, and we'll kind of go over those again before we get into the manuals here. But all of these devices flush lines one way or another. It just depends on what you're looking for as far as a goal, or really what your need. It really focuses on what your need is on that particular dead end main, okay? But flushing is just one part of a comprehensive approach. You know, tank turnover strategies are very important. Tank mixing is very important. Remember, the clock starts when the chlorine hits the water on disinfection byproducts. So if you have long tank turnover times, 2, 3, 4 days, your water's already old before it's getting into the distribution system itself. So you want to keep those tank turnover times low. You want to have mixing in your tanks if you can, to make sure that you try and keep those DBPs at bay before it actually goes out into the distribution system. Source water treatment, booster disinfection. There's a lot of different things you can do to improve your water quality. Flushing is a part of this. It's a very essential part of maintaining new water in your system and getting rid of old water in the system so that your residuals can stay steady and your disinfection byproducts can be held at minimums or less. Like we've talked about in the past, we have some tools that can help you improve your water system. The key with dead end mains is, if I have 100 dead ends in my system, my experience has been, and I've worked with water systems east, west, north, south in the US, Canada, Australia. If I have 100 dead ends in my system, usually 85% of my dead ends are fine. Short cul-de-sacs, lots of houses on the line. They turn the lines over every day, every 2 days, every 3 days at the most. It's figuring out where that 10 or 15% of my dead ends are that are bad ones, where my water is having aging issues. And these are some tools that can help you figure out where those dead ends are. The first one here at the top is a booklet. I can send one of these out to you in the mail if you like. It's a water quality booklet that basically sets up pages that you see here on the screen, where across the top of that chart is the length of your dead end in miles, 1/10 of a mile, from 1/10 of a mile to 5 miles long. So if I know how long the pipe is and how big the pipe is, I can calculate how much water is in the pipe. So the top of that axis there in that chart is the length of the dead end. The page itself is a diameter. So each page is a different diameter, 4 inch, 6 inch, 8 inch. So this is like a 6 inch page. So I have a 6 inch pipe that's so long. And then on the other axis of this particular chart at the top is the number of service connections, up to 35. So if I know I have 12 houses on the line and the line is so long, I can go over and find the corresponding cell, and it gives me a number, 4, 2, 6, 8, 10, whatever it might be. And that's the average amount of days it takes that number of service connections to turn that particular line. Most houses on average in the US use about 350 gallons of water a day. washing clothes, washing dishes, taking showers, drinking water, cooking, so on and so forth. In the summertime, a lot of irrigation. So on average, households use about 350 gallons of water a day. If you're out in the West, Denver West, it's about half that amount. But know that on average, most houses use about 350 gallons of water a day. So that if I know how many houses are on the line, and I know how long the pipe is and how big the pipe is, I can calculate the number of days it takes on average for those houses to turn the line. And that's what this particular booklet does. It gives you different pages for pipe sizes, and you can look on here to see how long your dead end is, how many contacts I have on the line connections, and I can see what that corresponding number is to how many days on average it's going to take. If I'm in the green section on the page, I'm usually getting into some bad aging water. If I'm in the blue section of the page, I'm usually good. So if you like a copy of this, you have my email, send me an email. I'm happy to mail them out to you today. We also have a calculator version of this as well. It's called the Water Quality Spreadsheet Calculator. And again, you can download this on our website, hydrants.com. It's under the Resource Center. It's just a spreadsheet. You fill in the blanks. What's my pipe size? How long is the dead end? How many service connections I have? What is my tank turnover time? And when you add in all that data, it'll calculate the same thing. How many days it's taking for those amount of service connections to turn the line. And in the red box at the bottom of the page there, it'll actually tell you how many minutes per day, if you have aging water issues on that dead end, how many minutes a day should you flush the line using like an automatic flusher that does 200 gallons a minute. If you're going to flush it with a fire hydrant doing 12 or 1,500 gallons a minute, you can adjust your time. But it gives you an idea how long you need to flush to turn that line over 100%. And then I can do the same thing with the distribution dead end analysis, the one with the multicolors on the page. I did this for a number of cities. Recently, I did one for a suburb in Fort Worth, where they sent me all the data on 135 dead ends. They knew they had water quality issues. They knew they couldn't buy 135 automatic flushers. They didn't need 135 automatic flushers. So they sent me their data, pipe size, length of dead end, number of service connections, and I put it all into a spreadsheet. I sorted it by age, and the red section was the bad dead ends that they had. Out of 135 bad dead ends, they had about 21 really bad dead ends. And then the orange and the other was kind of around 4 to 7 days, 8 days, kind of in the middle. And then the green ones were all the lines that were turning over every day, every other day, every third day, but they really didn't need any issues. So the majority of, and this is what I find when I do this exercise for almost every city, the majority of the dead ends, 80, 85% of them are green. We don't have to flush those lines really in particular unless you have a call about my water looks bad, my water tastes bad, my water smells bad, whatever it might be. And you can go out and manually flush those lines. Can do this at free charge. If you want to send me the information, I'm happy to do the analysis. I'll work up the data, I'll send recommendations, and I'll send it up to you, and you can take that data and you can do whatever you like. Another device that we have to help you figure out where your water issues are is this portable intelligent monitoring and flushing station. So this is the high-tech version of finding out what your water quality is doing. The nice thing about this device is that it attaches to any fire hydrant. 2.5-inch NST connection. We can do other swivel threads. If you have a special thread, we can do that as well. Or we can send you the device without the thread and you can add that yourself. This attaches to a fire hydrant, and this is a device that operates on a 24-volt lithium-ion battery with a solar recharger. And basically you have sensors and a PLC in this one. So you can actually put sensors in for chlorine. I can put sensors in for turbidity, pH, PSI, temperature, so on and so forth. And what you do with this device is you tell the device, I want to maintain a parameter of water quality. So I want to flush, I want to make sure that my minimum residual on this line is a 1.5 and the desired level of a 2.0, and I want to sample the water twice a day. The device will turn on when it comes to the sampling time. It will flush some water. It will get a fresh flow of water in the flow cell. It'll take that sample. If I'm below 1.5, it'll flush the exact amount of water until it hits the 2.0. It collects data. It transmits the data on the water quality for both chlorine and PSI and pH and temperature and so on and so forth, right from the station to a phone, a SCADA system, a laptop, wherever you want to send the data. It has a wireless gateway in the device itself where it can transmit the data. So it'll hold those parameters for you over time. So this is an analytical tool I can attach to a fire hydrant, collect data for a couple of weeks, and then I can move it around my system to different spots and see what's going on in different areas of my system. It's really a cool device to research water quality information in different parts of your system and find out what's going on. Then once you get the data from the station, you can make decisions on adding booster stations, automatic flushers, whatever you might need, or no action is needed at the time, depending on what comes back with the real data that you get from this particular device. So we can do demos on these. If you want to actually see this in action, we can come out to your place. We can hook up the hydrant and show you how it works. Once, of course, COVID kind of eases and we can kind of get back out into the world again, we're happy to do that. So these are tools that help you figure out where your problems are. And then based on the data, you can take actions on certain dead ends like we talked about with that suburb in Texas that I worked with. So in the past, over the past couple of weeks, we talked about intelligent flushing, like that portable device that we talked about where you hook it onto a fire hydrant. We have permanent stations that do the same thing. So these are devices that if you're looking to get real-time water quality data and have that data transmitted in real time to you, that's what intelligent flushing is for. Figuring out what's going on in different zones of your distribution system. If I have large mains where it's hard to hold a residual, another good application, a lot of applications for intelligent flushing. We have both portable and permanent stations. Automatic flushers we looked at in the past, they're primarily for turning dead end lines. So if you figure out, hey, I got 12 bad dead ends in my system and I need to turn these lines within a week, every week, that's the device that I recommend for dead ends. Not an intelligent device, an automatic flusher. They're not very expensive. I hook it onto a fire hydrant or I tap the main as the permanent station. I program a controller and it just does the daytime duration flow. I flush Monday, Wednesday, Friday, 2 o'clock in the morning for 30 minutes. And the timer just runs the whole operation where it flushes the line. Doesn't collect any data, doesn't transmit any data. It just turns those lines and make sure your residuals stay very steady. And then of course you get rid of that old water before disinfection byproduct form. Conventional or manual flushing is what we've been doing for a long time, flushing fire hydrants, flushing blow-offs. These are important devices to have on dead ends so that you have something to flush the dead end with. If it's a fire hydrant, great. If you don't need a fire protection at the dead end, if there's no houses at the very dead end of the dead end, usually blow-offs work very well, 2-inch blow-offs, and they're a lot less expensive, usually a quarter to a third of the cost, probably a quarter of the cost are blow-offs compared to a fire hydrant. So if you don't need a fire hydrant on that dead end because there's no house to protect for fire protection, usually 2-inch blow-off works very well for what you're trying to do. And that's what we're going to look at today is a number of different above grade and below grade conventional flushing. These are things that you put in your spec. So if they're going to build a new neighborhood and you have dead ends in your spec, this is what you put in your spec so that they put these on the dead ends every time they build something new in your system. So you usually create some type of spec and then you have these installed per your spec. So let's jump in and take a look at a number of different types of 2-inch blow-offs that we have for manual flushing. This is where someone actually physically goes out to the dead end, opens up the hydrant and flushes the blow-off or the 2-inch hydrant. So the first one we'll look at is this Eclipse 2 series, which many of you are probably familiar with. We've made this particular hydrant here, the number 2 Eclipse, for over 100 years in different iterations. Kupferle started in 1857. We started making these in the late 1800s. The early versions of these, we make lamps and puppy dog hydrants, so novelty items now with the nice fluted standing top stocks and so on and so forth. So we do novelty items with the original cast. This is the current version. It's called the number 2. It's a 2-inch blow-off. It's a post hydrant. So it's going to look like this. It's a post hydrant that specifically designed, and it's designed for flushing. That's all these things are designed for, is to flush lines. We do have a 2-nozzle option. A lot of plants like to use this for wash down. So they'll have a 2.5-inch NSC nozzle, and then they'll have a garden hose connection where they can hook up whatever hose they need, depending on what they need to clean up. But it can also be effective in other installations if you're looking for a 2-nozzle hookup. All brass working parts, multiple inlets. So this one you can do anything from a 2-inch IP inlet, like shown here is a 2-inch MJ. You're going to do a 2-inch IP all the way up to a 4-inch MJ. And we're the only manufacturer that can do a 4-inch MJ on a 2-inch post hydrant like this. So if you like to have a 4-inch MJ connection, we can do a 4-inch MJ connection on this 2-inch post hydrant. All of our products are fully serviceable from above ground. If you have any issues, you turn off the water, you pull the guts. Never dig it up. We can do all the repairs from above ground. And flow rates on this are pretty good, 675 to 75 PSI. So this is a hydrant that many rural systems use. A lot of cities use this in their neighborhoods. It looks like a little baby fire hydrant, so that's why a lot of people like the look of this one. It kind of looks like a fire hydrant, blends into the infrastructure very well. This is what the cut sheet looks on it. This is what the spec looks like on it. So again, it's just a 2-inch post hydrant that looks like a little baby fire hydrant. Another hydrant in the same series is the 85. The 85 is the exact same hydrant as the number 2 below ground. So this bottom part of this is the same. The only difference is instead of having a top stock that looks like a baby fire hydrant, this is a box hydrant. So we have a box on top of the lower section of this. And if you see in the picture here, it has an operating nut and a place where I can attach a riser. It's a lockable box, so it sits at grade level, but it's the same hydrant basically as the number 2, but it's a box version of this hydrant. So it's going to look like this in the ground, right flush with the ground level. So if you want something that's out of sight, off of a sidewalk or something like that, these work very well. They can be in concrete. You can put them in concrete, again, at level with the grade. So it's a below grade, level with the grade, post hydrant without the top stock on there. And we'll take a look at the number 2 here in a minute. Another popular one that we have is this one called the 77. This is the 77, 78 series. Again, a 2-inch blow off. This is a 2-pipe design. So this is a little unique in that the number 2 that we just looked at, and we'll look at that here, when you pull the plunger up, when you open it up, like a fire hydrant, the water goes around the plunger, just like a fire hydrant. So it comes up and the water goes around the plunger. This one has a little different design in that it has a 2-pipe design where the plunger is down here. As you can see here, it's closed in the closed position. And I can actually throttle this one from about 1/4 of the way open to all the way open. So I don't have to open this one all the way before the weep hole is closed. All these hydrants weep to ground just like a fire hydrant. So they're freezeless hydrants that you can use year round in whatever area that you're in. We do deep buries of these, especially up in Calgary, Alberta, and that area up in the Alberta province. We do 10-foot buries in some places up there. So a lot of these we can do, but the plunger comes up out of the way and you see the water bypasses the plunger. So the plunger comes out of the way and the water goes past it into the second pipe. So you can flush really a lot more debris with a hydrant like this because I don't have to worry about it going around the plunger itself. It has a free flow. Once that plunger comes up all the way and out of the way, you get a free flow of water. Flow rates on this, about 380 gallons per minute at 75 PSI. 2.5-inch NST outlet, just like the number 2. Standard fire hydrant thread hose. So if you want to use it to hook up hoses, you can do that as well. Has a built-in traffic breakaway. It has a locking cover that goes over so you can lock it up. No one can try and use the hydrant. The operating nut is a curb stop, so it's a wrench that you already have on your truck, so it makes it very convenient. The one on the number 2 is a pent, just like a fire hydrant, so you have a pent, a nut on the number 2. So again, a simple wrench that you have on the truck. And again, you can do all the servicing above this, above ground, and I'll show you how that looks here in just a minute. So this is going to look in the ground like this. So it's buried in the ground. The top part sticks up, basically where you see the black line on the sample back here. That's the ground line, and then the rest of it's above grade. Okay, so this is an above grade, again, blow off post hydrant. A little less expensive than the number 2, about half the cost. Number 2s run about $1,000 on average. Each these are going to run more like $500–600 each list. The 78 is the same hydrant as the 77, but it's a below grade version. So it's going to look like this in the ground. It's in a meter box. A lot of these are used mid-Atlantic, the Carolinas, Virginia uses a lot of these hydrants. Washington State and Oregon use a ton of these. They pretty much have them spec'd all throughout those regions. So those are certain areas that really use this hydrant a lot. Just goes into a standard meter box, 45-degree nozzle. Again, 2.5 NST, so I can just blow out right out of the box, or I can connect the hose if I like to as well. Again, lockable curb stop operating nut, just like the 77, but this is a below grade version that fits inside of a meter box, okay? All the other features are basically the same as the 77, just a below grade version of the same hydrant. Now, both of these have a big brother and sister, and that's one called the 7500 and the 7600. It's the same hydrants as the 77 and the 78, but these are 4-inch, blow off. So these can really move a lot of water, comparable to fire hydrants. So if you're doing unidirectional flushing and you need to get that 5 feet per second flow to get the scouring power going, this hydrant can move those. A lot of engineers like this hydrant. They put them in transmission lines a lot of times to blow off large transmission lines or large mains in particular, because it can move a lot of water at about half the cost of a fire hydrant. The nice thing is about these as well is that the flow rate is about 1,395 gallons a minute, which I didn't get on here before we had the session, but that's okay. Same valve design, just in a 4-inch model. So again, this is going to go into the ground and be above grade, just like the 77. It's going to look like this. Again, half underground, and then the operating nut and the blow-up portion above grade. So these can do flow rates comparable to fire hydrants at half the cost of a fire hydrant. So if you're looking for something to do a lot of water flushing for manual flushing, like a fire hydrant, the design is better though, because the nice thing about this design again is a valve. When the valve comes up out of the way, the water bypasses the plunger, unlike a fire hydrant. So you don't get a lot of scarring of your seats and your O-rings, and you can usually pass debris up to about 3 1/4 inches out of this one. So you can get a lot of debris out of this particular one. So especially if you're using unidirectional flushing, these are very good ones to use when I'm sweeping those pipes to a certain direction. I'm going to flush it out of the system. This is the device you want to use to flush out of the system. And probably more likely this version, which is the 7600, that's below grade. So this, like the other one, is in a meter box. Below grade, I attach my riser. This is a great hydrant for unidirectional flushing. When I'm sweeping all of my debris to one area and I'm going to flush it out of a certain hydrant, this would be a great hydrant to use to flush that debris out of the system when you do your unidirectional flushing, because again, the plunger moves up and out of the way, and you can get a lot of debris out this without damaging your actual hydrant itself like you would a fire hydrant. So we call these the 4-inch hydrants. These are on steroids compared to the 77 and 78. These are the big brother and sisters that are on steroids because they can flush a lot of water like a fire hydrant for about half the cost. Another interesting series of blow-offs that we sell a lot of, because I see a certain spec around the country everywhere I go. It's a spec that we call the homemade spec. And the homemade spec looks like this. Many systems have a spec like this in their system. We call it a homemade because basically you build it yourself. This is a gate valve. So if I have a gate valve in one 5 1/4 inch valve box, and then I have an attachment for a 2-inch riser in another valve box. So it's a 2 valve box design. Now, if I'm in warm climates where it's not quite as cold or the depth of bury isn't as deep, I could have a curb stop in that first valve box, or I could have a ball valve. So usually I see 1 of 3 things in that first valve box, usually a gate valve, a curb stop, or a ball valve operating nut. The problem with this setup, it's easy to build and everything's great until the gate valve or a ball valve or a curb stop goes bad from turning it on and off over time. They'll leak. And when they go bad, I have to tear the entire assembly up and I have to rebuild the assembly because I have to replace that operating mechanism, whether it's a gate valve, curb stop, or ball valve. So what we created was a blow-off that fits inside of a 5 1/4 inch valve box. And this is one called the TF500. This is for cold climates. All the other hydrants we looked at now can be used either in warm or cold climates because the valves are all below the frost line, okay, but down below the ground. This one has a warm climate counterpart that we'll talk about in a minute. This is the cold climate version because my valve and my weep hole are down below the frost line on this particular one. So this fits in a 5 1/4 inch valve box. So it looks like this in the ground. Basically, the operator would come, they'd take the lid off the valve box, they would thread on the riser under where this white cap is. You take this white cap off and I have a 2-inch thread on my riser. And then the operating nut is right here at the top. It's a square 9/16 operating nut, and we have the wrench that goes with this. And they just open it up and they flush the hydrant inside the valve box itself. So the nice thing about this particular one is it has a very small footprint. And what you would do with this hydrant is you would attach it where this riser is. So you don't even have to change your infrastructure. You can open up that second valve box and I can thread this one right on where my connection is down here at that elbow. Right here at that 90, I take this pipe out and I just thread the entire TF500 inside the valve box and close the lid so it sits below grade. I don't have to change anything in my spec as far as the infrastructure that's there. But now that I put that TF500 in that valve box, I can leave this gate valve or this curb stop or this ball valve in the open position. I don't use that as my exercising operating mechanism anymore because I have a operating nut on top of this hydrant, on top of this blow off called the TF500. So that means my gate valve, my curb stop, my ball valve is going to last a lot longer because it's going to stay in the open position. The only time I'll ever close that mechanism is when I need to do maintenance on this particular blow off inside the 5.25-inch valve box. And you can put all the guts right from the ground level so you don't even have to do any digging with this one as well. So once I show this to a number of systems that have this homemade setup and they see this hydrant and how it's designed to work, it's like a no-brainer. No one likes to dig up stuff. So if this avoids me, this keeps me from digging up anything, hey, that's great. We have a number of cities who may not replace all their dead ends with this, but when this one goes bad, they have the new spec where when they rebuild this one, they put the TF500 in there. Or you can actually put it in all your existing homemade setups that you have, like we talked about. So I can replace them all right away, or I can put in my spec, and anytime this gate valve goes bad, I don't even have to put the gate valve back in. I can just put the TF500 at the end here, and if there's another shutoff up the line, I can use that other shutoff to turn off the water to do maintenance. If there's not, you need to replace your operating mechanism. But if there is another connection up the line where I can turn it off, you can just skip putting that gate valve or that curb stop or that ball valve altogether once again. So it's going to look like this in the ground. Here's my 5.25 standard valve box. It sits below. Here's the cap that covers up my 2-inch connection. I just thread that off. I put my riser on. Here's my operating nut. I put my wrench on there. I open it up, close it just like a fire hydrant. This has an operating rod and a seat. We'll take a look at that here in a minute. This is what it's going to look like in the ground, underneath the ground here. So this is called the TF500. Very successful hydrant, very smart hydrant. It weeps, has the weep hole right here in the middle of the valve. The valve is designed so, again, the plunger comes up inside this compartment and the water bypasses the plunger. So I don't have a lot of scarring of the seat and the O-rings because the plunger comes up into its own pocket and the water goes around these channels on either side, up and out. So you get a good flow rate on this, about 400 gallons per minute at 75 PSI. It's just a smart little hydrant. If you have that homemade setup, I really recommend you getting 1 or 2 or 3 of these and trying them out. We have special pricing for all of our products for spec evaluation. So if you want to get a couple in your hands, put them into your system, try them out, see what you think. I'd highly recommend that. Email me, I can get you some more information on that as well. If you're living in a warm climate area, we have the same type of hydrant here, but this one is for a wet barrel. So it's still a hydrant design. I'll show you what the insides look like. It's a plunger design, as you can see here from the picture, but it just fits onto a 2-inch line that's a wet barrel. So this is Florida, Southern Texas, Arizona, California, places where they don't have freezing. It's the same type of blow-off that fits in a 5.25 valve box. I just don't have an operating rod and a plunger. I have a very short plunger and a very short operating rod that just fits into the housing of this particular device and just threads onto a 2-inch pipe that's a wet barrel all the time. So there's no weep hole with this one because you don't need it because of the freezing issue. There's no freezing issues in those particular parts of the country. I always like to tell people who are living in Florida and South Texas and Arizona, you don't know how easy you have it down here because basically you're doing outdoor plumbing. You don't have to worry about freezing or anything like that. It's very much simpler than trying to do waterworks in Calgary or Ontario or places like that, cold, very cold places, Montana. So these are some of the blow-offs that we do for manual. And what these are designed to do, these are designed for those dead ends where you don't need a lot of maintenance. You don't have to flush it every week because I don't have water quality issues. These are for your specs to go on the dead ends. So if I do need to flush a line, I have a good working hydrant blow-off that I can operate from above ground. I can repair from above ground, or I can flush the line when I need to flush the line. But it's not really something that's going to work on water quality unless you have a bad dead end. You go out and flush this thing manually every week. If you have one of those types of bad dead ends, I would focus on automatic flushers. So the 100 dead ends that we have in our system, this is the one that goes on the 80 to 85% of those. And then the automatic flushers go on that 10 to 15% of the bad ones like we talked about before. Okay. Let's see, any questions at this point? Anybody have any questions? If you want to unmute your mic and ask a question or do a chat text at the bottom here. If not, we'll go on and I'll show you some examples of the hydrants themselves, how we do maintenance on them and so on and so forth. So let's go ahead and do that. I'm going to stop sharing here. Okay. There we go. All right. So I have some of these lined up back here. I'll try and get to where you can see a lot of these things. Let's take a look at the number 2 first. The number 2, again, is a post hydrant that we've been making for a long, long time. This one actually has a 4-inch MJ. So again, I have my inlets anywhere from a 2-inch up to a 4-inch MJ. Operating rod with a plunger design, 2.5-inch NST nozzle. We can do other sizes on the inlets and on the nozzles. So anything up to a 2.5 NST, if you want a 3/4-inch garden hose, if you want a 1-inch, we can do anything you like on the outlets. Inlets anywhere from a 2-inch FIP all the way up to a 4-inch MJ and in between. So a lot of choices with this hydrant on inlets and outlets. To do maintenance on this, it's very simple. I turn the water off to the water line. I open up the hydrant to get that plunger to come up out of that seat. It makes it easier to pull the guts on this one. And then I have 4 bolts on the top. I take the bolts off, and I can take off the whole operating rod. And the only maintenance that we do on this particular one is we have a rubber seat, and we have O-rings on the nozzle down here, 2 O-rings. So this is the maintenance on the number 2. It's a hydrant design that closes against the pressure. We close against the pressure, not with the pressure like a fire hydrant. So I don't need a seat ring, a seat wrench, or anything to try and get this thing apart. All right. So the number 2 is very popular hydrant. People have been using these for a long, long time. We still have racks and racks of these that go out every day. The 77 is the other hydrant that's probably our second most popular one. And this is this one here. Again, where I bury the hydrant in the ground, right at the black line here. So this is above grade, this is low grade. It has a locking collar. This one we can do a locking on the number 2 as well. If you want to have a lock, we can do that as well. This one has a locking cap. Curb stop operating nut. Okay. 2.5-inch NST outlet. Again, on these, we can do a 2-inch inlet, either a straight or a side inlet. And we can do up to a 2-inch MJ on these. So either a 2-inch IP, vertical or horizontal, or we can do a 2-inch MJ horizontal. To do maintenance on this and the 78, which is the green one next door here, this is the below grade version. This one fits in the meter box. This one's above ground. Again, to do maintenance, I turn the water off, 2 bolts, I take them out. Again, I can pull the whole guts right here. To do maintenance on this one, it's very simple. We have a seat, 2 O-rings here. So I just get a repair kit. I do my repair, put it back in, turn on the water, and away we go. So very easy to do maintenance on the 78 as well. We bolt it, turn on the water, I'm ready to go. This is the TF500 that fits in that 5.25-inch valve box. The one that goes into that homemade assembly, okay? So again, I have the 2-channel valve with the weak hole down here. My operating nut is here. I have the cap that goes on to keep it clean while it's underground. When I come to flush the hydrant, I take the cap off, I attach my riser, I turn my operating nut, and I flush the line like we saw in that picture. To do maintenance, again, turn off the water, 4 bolts, I pull the guts, operating rod, again, the seat here, I have 3 O-rings and a seat. I get a repair kit, I do the repair, I put it back together, and away we go. So this is for the cold climate. For the warm climate, it's the TF550. And that's this one here. So this just goes onto a 2-inch connection. It's for warm climates, not freezing. And again, the guts, it's just, again, a plunger design, but a short plunger with the seat. So the only maintenance I do on this is I replace the seat, put it back in, turn on the water, and again, away we go. So all of these blow-offs are designed to flush those dead-end lines that you really don't have water quality issues with, that you need to flush on a regular basis. That's what automatic flushes are for. But the majority of your lines are going to have something like this on a dead end, whether it's a blow-off or a fire hydrant. If you have that homemade one, I'd really recommend trying to get one of these TF500s or TF550s, depending if you're cold or warm climate, and trying these out. They're really a neat hydrant, and you'll never have to dig up that assembly for those homemade blow-offs again. And of course, they always go bad in January, February, the time when you don't want to do the digging on this. So this is our line of manual blow-offs, manual hydrants that go on dead ends. Anybody have any questions on anything with the details, the maintenance? On our website, we have short videos on all these products. So if you go to hydrants.com and you go to the product page, let's say you're looking at the TF500, there'll be a video on that page where you can click on it. It'll show you the features, operations, and maintenance on the video, on a live hydrant, so you can see how it flushes, how it looks flushing, so on and so forth. You can see the below grade picture of that as well. So hydrants.com, any of our products, not all of them have videos, but the vast majority have a short 3-minute video, features, operation, maintenance. I encourage you to go there and take a look if there's anything that you have interest in. If you have any other questions or need any more information about anything, you have my email, and we'll go ahead and let you contact me, and we can get you more information on what you might need. So if there aren't any other questions, we'll say thank you very much for attending again today. Our last webinar will be this Thursday. We're going to do sampling stations again. And we're doing sampling stations again because it's a very popular subject right now with this COVID. A lot of utilities are trying to get out of homes and businesses. So a lot of interest in sampling stations right now. So we're going to do sampling stations again. If you want to join us, let me know. I'll send you an invitation. And we'll hopefully see you out on the road with our product vans. We're hoping to get out maybe end of June, early July. We'll see how things go. But hopefully we'll see you this year before the year ends out on the road and come by and see you actually at your utility. So thanks for attending, and we'll go ahead and close it out now. Have a great rest of your day.